In this class, we will learn about locus of a point. Many students will confuse to understand the definition of locus of a point. Actual definition of locus of a point is the set of all points in a plane which satisfies given geometrical condition is called locus of a point. I repeat, the set of all points in a plane which satisfies given geometrical condition is called locus of a point. But here I changed the definition a little bit so that you can understand it easily. This is very important definition. Try to understand what is happening exactly. Locus of a point. You observe here, P of x comma y is a variable point. P of x comma y is a variable point. Here variable point, fixed point, two type of things will be there. Variable point means the values of x and y will changes. That means the point P is not a fixed point. It moves from one place to another place. What I written here? Let P of x comma y is a variable point such that which moves, that means the point P moves under given geometrical condition. In the question only they will give some condition. Based on that condition, this point P moves. Then this point P moves na, the point P moves na, where it is moving, that path is traced out. The path traced out by the point P is called locus of a point P. I repeat, P of x comma y is a variable point which moves under given geometrical condition. This is the point which moves under given geometrical condition. As this point P moves from one place to another place based on given geometrical condition, we will get the what way the point P is moving. If we trace out that point, the path traced out by the point P is called locus of the point P. I'll try to explain this with the help of examples. You see here, I considered a fixed point C. The set of all points in a plane which are at a constant distance from this point C. Suppose you take this CP. That means the distance from C to P, CP, this distance is suppose R, you suppose this distance is R. If you find out the point P in some other place, here if you find out the point here, this length is what? As you know regarding circles, what is this length? This length is also R. What I am trying to say here, initially C is the fixed point. Okay, initially C is the fixed point. The set of all points in a plane which are at a constant distance from the point C. So if I identify what type of points I'll get here point P, here I'll get point P. What all these things? If this length is what? This length is R, because this length is R. This length is also R. Try to understand what I am saying. C is the fixed point. P is the variable point here. P moves. P moves in what way? Such that the distance from P to C is constant. This distance is 5 units, means this distance is also 5 units. Like that, the point P is moving. So then you will get the points like this. This is the point. This is the point. Wherever you take this is R units only. Suppose if we take this, if you take this as the point P, this is R units. If you take this as the point, this is R units. If you join all these points, what you are going to get? The path traced out by the point P is called locus of the point. Try to understand. Here C is the fixed point. Here C is the fixed point. The point P is a variable point. It moves. In what way it moves? What is the geometrical condition? It moves such that its distance from fixed point is constant. They are saying that condition is the point P moves. In what way it moves? The distance from P to C is always same. So suppose this distance is R units means this distance is also R units. This distance also R units. This distance also R units. This distance also R units. Like that it is moving. I should consider such type of points only. I cannot take point P here. I cannot take point P because they are saying P is moving such that its distance from fixed point is constant. The constant distance. If that is the condition, try to understand this geometrical condition varies from example to example. In this example, what I am saying, the P is a variable point, C is a fixed point. The point P moves such that its distance from fixed point is always constant. If I consider like that, the point we will get like this. This is the variable point P. This is the variable point P. If I join all these points, what I am getting? I am getting a circle. So locus of this point P is what here? Locus of this point P is a circle. I hope you are understanding. See, what is the locus? The path traced out by the point P is called locus of the point P. In this example, what is the condition here? C is the fixed point. P is a variable point such that the distance from C to P is always constant. At a constant distance. That means this distance is what? This distance is also same like that. Then for that example, what is locus of point P? Locus of point P is a circle. I hope you understand this. I'll try to explain this definition with another example. You see, this is a second example. A, B, two fixed points are there here. A and B are two fixed points. P is a point. Try to understand clearly. P is a point such that which is equidistant from A and B. Try to understand. What is the question? A and B are two fixed points. And P is a point which moves such that it is equidistant from A and B. That is the given in the question. P is a point which is equidistant from A and B. If that is given like that, where I should consider the second point? Can I consider second point P here? P is equidistant from A and B. If I take a point P here, is P is equidistant from A and B? No, you cannot choose like this. If I take a point P here, is P is equidistant from A and B? No. So where I should consider? If I consider a point P, there is a chance. Yes, possibility is that PA equal to PB. So here I can find a point P which is equidistant from A and B. Here also I can find, like this. I will get the points like this. If P is a point, what is this point? It is equidistance from A and B. Like this I am going to get the points. Please try to understand. Based on the condition, the point P is moving like this. Because what is the condition here? P is equidistance from A and B. If I join all these points, the path traced out by the point P, if we join all these points, what I am getting? I am getting a straight line. I hope you are understanding. I'll repeat. A and B are two fixed points. P is a variable point which moves such that it is equidistant from A and B. This distance is same as this distance. Like that it is moving. You take anywhere point P which is equidistant from A and B. I cannot choose the point P here because clearly I can say P is not equidistant from A and B. So based on the condition, we will get a curve. That curve may be straight line or it may be curve. The curve may be straight line or it may be curve. Here I just taken two small examples. Based on the condition, sometimes you will get parabola. Based on the condition, sometimes you will get ellipse. Like that, different shapes we will get. I hope you are understanding. What is locus of a point? Let P of x comma y is a variable point such that which moves under given geometrical condition. Then the path traced out by the point P is called locus of a point P. What the main point here? Locus of a point means it is a curve. That curve may be circle, the curve may be straight line, the curve may be parabola. It based on the given condition. Okay. So in another words, we can say locus of a point definition like this also. The set of all points in a plane which satisfies given geometrical condition is called locus of a point. I hope you understand this class. In next class, we will learn about how to find equation for locus of a point.